Hello and welcome to part 6 of the WUDSN IDE tutorial. This time I will show you the heart of the IDE, the heart of my plugin, the one thing that I never thought it would happen when I started implementation, and it is the content outline and the navigation within the IDE. Okay, let's start with the most important navigation. Imagine you have opened that file and now you wonder where it is in your source tree. Then you have two locations where you can navigate. You can choose to navigate show in Project Explorer. For text files the same is available here, which is normally easier to find, and you can say show in Project Explorer, and now you see it opens the file path and navigates to that file. That is an easy navigation. The more complex navigations will follow. You can open files and click back to navigate between them, also between editing locations. But now for the outline. The outline is an Eclipse standard type of view. It is here. Once it is hidden or closed, you can open it again, either via the shortcut or via the outline. What does the outline do? The outline is the content outline of your current source file. So depending on the source file that is open, you see an outline here. I can open a different file and you see the different outline content is displayed. So what is now supported by the outline? The outline is linked with a parser. This is a rather simple parser that it works line by line. It is not a complete compiler, therefore there are some restrictions compared to the actual compile process, but for 99% of the cases this parser is able to parse and understand what you are typing here. It really does this while you are typing, so if I say new label and I set it to 1, you see it has added a new label here and expanded possibly affected source sections. What are the type of sections that are available? The first section, where no code is always the definition section. It contains definitions of macros, equals, and maybe labels. Then, when you start with an awk statement or a similar statement, code starts and an implementation section begins. In Atari, it is in Atari executables, and in most other compilers it is the case that you can have multiple implementation sections. And as you can see here, navigation also works via the outline. So I can click here and I end up on exactly this location where this label or section begins or was defined. Okay, what other types of sections are detected by the outline and the parser? You see a lot of different icons here. So first of all, there are equals, namely constants. Then there can be labels, which are pointers to some memory location. Maths supports this notion of a local section. So there is a begin and an end statement, and it can contain inner labels. In this case, the outline is also hierarchical, so you can choose to expand or collapse the outline here. You can also choose to expand and collapse the source here. This also works for larger portions of the source. If you hover this plus sign, you get what you have actually collapsed. Then there are macros, other macro definitions. There are pages. This is also a begin-end type of directive in maths. And the most important one, procedures, subroutines. Most of these things can be nested. So here you can have a procedure and a procedure which contains a macro. This is also supported by the parser, so you can also navigate down here and collapse it all and get a tooltip on it. Repeat sections, and yeah, basically that's the different type of sections there are. Besides that, there is support for binary and source includes. So what does it mean? If I go here then normally every compiler has the notion of a source include directive. In METS it is ICL for include. And if I press now Control, then we are again working with navigation. You are hyperlinked navigation to a source include. I click Control, hover this link, get this finger pointer, and if I click on that link, I end up in that source include. Some compilers support default extensions. So if your source contains something like this and it is METS, the default extension for METS is ASM. So even though there is no file named exactly like this, the forward navigation will work. Besides source navigation, which always opens the linked or included file with the same editor that you have currently open, there is binary include. There are binary includes. For example, this is a binary include, and here you get multiple options. You can choose to open it with the hex editor, which is part of WUDSN IDE. It will be tackled in detail in a separate tutorial. All you need to know is there it is. You see the length, you see the content, you can scroll through it, and there are some options how you can copy content or visualize content. And what you also see is there is a graphics editor. So when I click on this, you end up in a very powerful display and conversion tool. This is still beta, but what you can see is it detects that this binary include contains a char set, and it visualizes the char set, so you can see which arrangement of the characters is in there. Absolute and relative paths are supported. So here in this example, and this is what you normally do, I have used relative paths. I can use a relative path like this. When I click on this, it will now tell me that this file does not exist, and you see that it has resolved this double dots to be the parent directory or the dot to be the current directory. This should work. Yes, it does. And of course you can also choose real absolute file paths. Don't know why this doesn't work now, but I've seen it working before. Okay, different types of structural elements. One thing that you don't see in the outline but only in the source is control statements. So if you have conditional compilation here, like with an if statement or a when or while statement, they don't have names, therefore they don't appear in the outline, but they are nesting operations. So what I can do is I can collapse this whole if statement into a single line, and also here the hovering works as expected. Okay, so we have that parser that runs in the background. We have these include files, which can be source files. What can I do with that? When I started 2 years ago, there was not much I did because the parser was very simple. So then at a certain point in time it was so good that I decided, okay, it is so fast, why not parse the source includes recursively? So the parser detects not only that this is a source include statement, it also really goes into that source file and parses it. Oh, what does it mean? That means in the outline you do not only see there is a binary include and there is a source include, you can also drill down into the other file even without being in that file. Yeah, if you really want to go there, you use navigation and you see, here is that inner code. A side effect of this is that now I finally had a complete parse tree with all the identifiers in that source. So I can not only navigate to files, I can actually navigate to labels. So here I click to the main label and to other labels and procedures. I can navigate back, I can navigate to equads as well as to macros. And now the two things that I'm very proud of, you can navigate to something that is not even in that file and it knows where it comes from. So if you click on that inner procedure, it navigates to the inner procedure in a completely different file because it knows where it comes from. As mentioned before, this parser is not a compiler. So if you have complex things like nested procedures or equally named things, it is not able to do it all or know it all. But it is able to detect what the possible matches are. So if there is an identifier which is not unique, it offers you the type, name, and the location in the different source files. So this could be the definition in that include, but it can be a macro as well as the procedure as they are defined here. Well, what's more to say about the outline? There's one feature that is helpful if you have files with lots of symbols. For example, definition of OS equals. So if you have it sorted like this, and you can choose to sort them or use them in the order as it is as they appear in the source. Normally for code it is useful to use the appearance as it is in the code. As mentioned, if you have a long equid label, equid definition file, then it may be helpful to find the equids if they are sorted alphabetically. Well, that's it for the most powerful feature. There will surely be improvements regarding the parsing and the highlighting, but tell me your opinions. Do you think this is useful? Especially in the next version, there will be a highlighting of the different types of identifiers where they are used. So you can choose different highlighting for the procedure colors, for the procedure labels, or macro identifiers, and so on. So, hope you like that. See you next time. Bye.